Thank you for inviting me. I'm always excited talking about blockchain and SAP. So I'm going to talk about blockchain as a service and how we can incentivize information exchange in SAP. So today we have a challenge that the world economy is stagnating. The industrial centralization is stagnating. We have reached an aggregated efficiency at 20%, and we cannot get over that. We actually reached that in the 80s, 90s. So with today's way, with the telecommunications, with the fuel-based energy systems, and the internal combustion engine transportation systems, we simply cannot get any more efficient than this. And this is a problem for the world growth. So the solution is, of course, the next industrial revolution, Industrial Revolution 5.0. We are currently in Industrial Revolution 4.0. So as you can see here, the first one was when we got machinery, steam machines and so on. Then we got electricity. Then we got computers in the 70s. Now we are in the internet area. And we are very, very close to go into the next area here when we are combining machines and humans together to increase the efficiency of production. We're also going more and more to decentralization. Until today, everything is going to centralization. Bigger factories, more centralized, but that is now changing because it doesn't make a purpose anymore to centralize more. Now it is decentralizing. We're also coming more and more into autonomous functionality, autonomous machines, autonomous economies. So what we have today, and going into the Industrial 5.0, is all this new technology that you all have heard about, like the advanced robotics, not automatic machines robotics, but electronics, robotics in software. We have the artificial intelligence, the cloud computing, software as a service and so on, all these sophisticated sensors, Internet of Things, big data analysis and so on. And we have the augmented reality, and we're coming more and more into this decentralization again, with 3D printers, with more and more autonomous machines, autonomous cars, drones, trucks, autonomous boats even, or ships. This creates complete new digital business models for us to use. And one big part for this to get into the Industrial 5.0 area is blockchain and cryptocurrencies. With blockchain and cryptocurrencies, we get decentralized money and decentralized payment systems. We get an economy of things, not only Internet of Things, but economy of things. Each thing itself can have its own economy. So we get true decentralized services, not like Uber and Airbnb. They are centralized, totally centralized systems, and has actually not very much about decentralization and sharing economy to do at all. We get something, we can say anything as a service with streaming payments now. We can have machine-to-machine payments. Previously, to have a bank account, you must have an organization number or a personal number to get a bank account. But today, machines can have a cryptocurrency account, and they can pay to each other. So that way, we get financial autonomy. Machines themselves can take care of their own economy of things. This creates totally new business models for us. So the marginal costs will fall to near zero. And the marginal costs means that when you have done the first product, when you have all the infrastructure already invested, just to make one more product will cost more or less nothing. Just like to make one song or one video, it costs a lot of money to make the first video, but then to make a copy of it costs almost nothing. Same here, that will come into all industry parts. That the first investment we have to do, but then the marginal cost to just make one more piece of that will close down to very close to zero. So we go from markets to networks. We go from ownership, that I own everything, to access. So instead of owning my own car, for example, I just rent a car when I need it. We go from consumers to prosumers. So we not only consume stuff, but we also create stuff, like we do on Facebook and all social medias. And we go from this old monthly payments, weekly payments, to streaming payments. We can pay every second, every millisecond. We can pay a little part instead of every month, which totally change our business models. To close this back to SAP, and SAP, a big part of SAP is to be part of supply chains. And when we talk about supply chains, it's a huge amount of money in the world. The total GDP is of $75 trillion, and supply chains is more than 2/3 of that. So $54 trillion is handled in the supply chains today. And then maybe you think, yeah, what is a supply chain? It's just someone producing something and selling something. But everything that we wear, everything that we own, computers, phones, everything that we eat, everything that we don't grow in the garden at home or create ourselves in the garage goes through a supply chain. And that employs over 3 billion people in the world. 3 billion people are employed in supply chain in one way or another. But we have challenges in the supply chains that we have today. As I said, the aggregated efficiency is too low, only 20%. We can't get higher than that. And 20% is from Japan. They are the most efficient of all. Like here in Europe, it's 17 or 18% or something. And I think that was in Germany even. So it's less than 20% efficiency in the world. So it's impossible to increase that marginal cost with this old technology. So what we get today is more and more sub-optimization. That every company or every factory is optimizing as much as they can, but in the big total supply chain, we're actually creating sub-optimization and higher costs in the total. We also have a problem of up-to-date information and correct information. And we have this slow and expensive economic system that hinders everything. And a lot of manual paperwork, of course. Especially in the transport industry, shipping industry, we still have a big bunches of paper that has to follow the containers or the freight. So the problem we have is that everything today is in closed silos. Every company have their own SAP system or other ERP systems, and they have their own databases, and they don't really want to share the information between them. But what we do today is building complicated and expensive integrations between companies. This is what I'm working with, building integrations between SAP and other systems, so I know exactly what that is. And we do the same at every company all the time. Same kind of interfaces, invoices, warehouse management, everything. Always the same kind of interfaces, but again and again and again, and changing. And these supply chains create huge gaps. So when we have an order and we change it, it has to travel the whole supply chain up before the supplier gets that information. Same with the invoice, it has to travel all the way down before all the money is paid to every part. Create huge gaps in information, gaps in time, liquidity gaps, and tied up capital. And when we think about the supply chain, we often type or make a drawing like this, but actually supply chain can look like this. It's more like a network of companies working together. And then think about all the gaps that we have in this system and all the money that is tied up in this system. There's actually $4 trillion tied up in global supply chains at any given time. And worst of all, 25%, 1/4 of all the machines and all the equipment, boats, trains, factories, 1/4 of them are not used at any given time. We only use 75%. Totally unsustainable, totally inefficient. So the solution should be to have one global universal source of truth, one global database that all companies could use. And this is exactly what blockchain can give to us. So we are not removing any SAP HANA databases. So SAP HANA is super efficient and very good to have internally, but to share data between us, we just add the blockchain functionality. So when the order is changed here, it doesn't have to travel from one partner to another. We can just distribute it to all at once, immediately, real time. Same with the payment. We now get a real-time settlement system. So instead of the producer sending an invoice to the distributor, sending an invoice to the company, sending an invoice, and so on, now we can just pay out, send the invoice and get paid directly in real time, if we like. We can also use this system for secure data sharing. If a drawing is changed, we can distribute that to each node that needs that information. And we get global traceability with this. If all system is connected to the same database or blockchain, we get a very nice global traceability system here. And then if we add the financial incentives to share information, now companies can sell and buy information. Today, it's a problem if a supplier, they have a lot of information about the product, but they don't really want to give it away. And maybe the distributor needs it, or another company needs that information, but today it's hard to get. Just imagine then if we can put a price on this information, and the company can just buy per piece, or per second, or per kilo, per unit, or whatever you like to have it, with streaming payments. Then we get a whole other economic system where the supplier, normally just sitting on this information, now can sell that information to the other nodes who needs that information, and can use that information to make their whole process more efficient. And we can have peer-to-peer secure messaging between the systems here. I will talk more about that. So what we're doing is we have our SAP system. We have this universal source of truth, UNISOT unit, which is connected to the blockchain, which gives us all the functionality in the blockchain in SAP, available in SAP. And that gives us blockchain as a service in SAP. We can have this unit in a cloud, just like we have SAP in the cloud, or we have it on premise, if that's more feasible. And what we get with this setup is that we get very secure information exchange. We get secure information storage, and we can share that information that we have stored. It's almost the same, but two different kind of. We can store information and then share it, or we can exchange information quicker. We get the global traceability, as I said, and we get provenance tracking. So provenance tracking means that we can see the original of products, where they are coming from, what has happened to them. And we get these digital twin objects and digital threads. We get digital tokens, so we can create tokens like you can do in blockchains. and smart contracts functionality. All of that we will get in SAP, available to use. We get a global settlement system because we have cryptocurrency. And we can set up private payment channels between the different nodes in the system, which means that we will come up to enormous amount of transactions per second. That's often an argument against cryptocurrencies, that it's only a couple of transactions per second. But not if you have private payment channels. Then you have more or less unlimited amount of transactions. So what we are doing in a supply chain network is then that every company then just adds this UNISOT node to their system and connects to the global blockchain. Very easy, and it's very cheap. It doesn't cost a fortune to do this because the global blockchain is available for free. What you need is the software to connect and the knowledge to connect. So what we do in this system is that we are connecting, you can't really see that, but that's a business partner screen in SAP. So we connect the business partner handling in SAP. We can connect with the system, which means that we get customer due diligence or partner due diligence, where we have know your customer, anti-monopoly law, and all of that stuff that we need to be sure who we are trading with. You can also have verification functions, either verified by the UNISOT system or verified by other partners in the supply chain. And there is an API in this system, so we can also connect to other systems than SAP. We can connect to manufacturing systems, to warehouse systems, other legacy systems that is at the customer site, and get all the functionality that we get from the blockchain. So now we have this secure peer-to-peer business communication. We don't have to build interfaces between every node or every company that we like to communicate. As long as they are on the blockchain or on the universal sort of truth system, we just have one integration that we have to do to the blockchain, and then we can communicate with them. And we can communicate with standard functionality like UBL, or it's called here AHF in Norway. UBL is the Universal Business Language. That is a universal standard for business communication, which have functionality for all the normal business functionality like purchase order, invoice, transport logistics, bill of loading, and all these different business documents that we need to send between us. But we can do this now very, very secure and encrypted with the blockchain system. We can do that today also with normal integration software and middlewares, but that's often rather expensive to do that. You have to buy expensive adapters, and you have to have experts in the integration system to build the integrations. Here we have it built into the system. So if you have a UNISOT node, you just communicate, encrypted directly, finished. We also have information exchange. So we can exchange information, as I said, and we incentivize by putting money. We monetize the information. So this company can sell information to another one and so on. And we can pay with streaming payments. We're not paying like a monthly bill, but we are paying per second or per unit or per gram. We can sell production data, material data, IoT data. If you have a lot of IoT sensors, you can actually sell that information to other partners in the system. And all kind of information that could be useful for other. We also get this functionality from the blockchain like smart contracts and tokens. So we can create tokens and we can create smart contracts in SAP and start using this functionality in SAP. And by this technology, we can create digital twin objects and get the digital threads. And we get this global traceability, as I will show here. The digital twins is actually when you have a physical object, like a salmon in Norway, you make a digital twin in the blockchain that you then can follow electronically the whole way in the supply chain. That could be a machine, an airplane, it could be a house, a factory, or it could be your health information that we are storing securely in the blockchain and can follow when that object is moving in the world. If it is a fish being sold or a salmon being sold to Japan, the digital object can follow to Japan, and we can follow it all the way electronically. If it's your health information, it can follow you on vacation. So you're on vacation in Spain and get sick, you can still get your information directly from the blockchain. You don't have to call home to Norway and get your medical records from there. It's already globally available if you have your keys to open it up. Everything is encrypted and very secure, of course. So we get this global product lifecycle management. So we are connecting the product lifecycle management from SAP into this system, which means that we can follow a product that's supposed to look like fish eggs. When you have small fish, you have they grow and then you harvest them. They get processed and we are transporting them, and it comes to your dinner table. And then, of course, not to forget the recycling of all of this. Not recycle of the fish, we handle that ourselves, but from the packaging and so on. This is what we call the digital thread, that we can follow this twin object all the way globally. We can then add information here, like if they get some kind of medicine, what kind of food they get, the water temperatures, when it was harvested, where, what sea, what company, what happened in the production facility, if there was a trouble in the refrigerated transport chain, we can get information about that, and so on. Every step here can store information with the digital twin at that point in time. Which means that if we see it from the other side here, a consumer here can get information about everything that happened to that fish. How old it is, how long it was transported, what kind of stuff was added in the production, what kind of food, what kind of medicine, and so on was added to that fish. And we get this ownership transfer of this because it's a digital object, a token that is changing ownership. Like that is a functionality that we have in blockchain. So we can follow that. And then because we have the cryptocurrency, we also have a global real-time settlement system. So we can do settlements, payments in real time, which can eliminate 90% of the financial costs. It's an incredible number. We can take away 90% of the financial costs for any company by using this. And if you are an international company doing a lot of international trades, you can save even more. And you can do these micropayments and streaming payments. So micropayments is like every minute or second. If you're talking streaming payments, it's every milliseconds. So like an example for streaming payments is if you're looking at a movie, you can actually pay per second that you're looking at the movie. And we get this, what is called decentralized exchanges, where you can exchange information, you can exchange objects, you can exchange tokens from other companies. So we can exchange information, raw material, excess materials, products, overproduction. We can exchange energy. There's already a lot of solutions to exchange energy between producer. If you have sun cells on your roof, you can actually sell that energy to others via blockchain and cryptocurrencies. We can exchange resources, machines, talents, and everything here. But the important thing is that this is decentralized exchanges. They are not existing on one central place, but they're existing in the whole system. So anybody can be a UNISOT partner. What we have done in our company, I'm from Sky Consulting, what we have done, we have made an industry solution in SAP for the fish farming industry. So we can also now in our SAP system have all the functionality to handle the fish farming. Everything from stamfisk, from the eggs, to all the way to your dinner table. So what we are doing is we are adding universal sort of truth, of course, and then we use the digital twin objects. So when the eggs is coming in, they are too small to actually put an RFID tag on. So we have to have it in batches. We have a batch of eggs. We put a RFID tag on that batch, and now we can follow that batch in the whole process. And we can have information about where the eggs came from, the father and mother of the eggs, and so on. The eggs grows to small fishes, still too small to identify, so we're still having batches here. But then when they are getting big enough to get put out in the sea, they are big enough that we can identify them either with an RFID tag or with facial recognition, with cameras. So you can follow the fish. It's in the sea here for half year or 1.5 years, and we can follow everything that happens, all the food that is given, the water temperatures and everything. And then they are harvested. We can follow when they were harvested, how long they were in the boat and so on, how long it took before they come into the factory where we are manufacturing something from it, where we are slicing up the fish in different slices. We can follow each slice of the fish if the factory have that functionality in their system. Then we can follow each slice of that fish into a new product, and we can see what kind of other items we have in that product, what kind of spices, what kind of sauces and everything else that goes into that product. And then we can follow that product, the rest of the supply chain, out to the shop and even out to the dinner table or the restaurant. That is what you can do with digital twin objects. And this is now, of course, you can do this in a normal database as well, but then someone, probably the biggest company here somewhere, is owning that database and they can manipulate with that data. That's the whole idea where we should have a blockchain instead, because nobody owns the blockchain. Everybody owns the blockchain, and nobody can manipulate the information that is put into the blockchain. So now all the companies, it's all different companies, can now trust one blockchain instead of trusting one database that someone owns. We can also add documents, of course, to the blockchain, all different kind of information that is needed for that product and for the fish in this case. We can add certificates to export salmon from Norway to China or to Europe. We need to have certificates so that we can also, of course, store this kind of documents in the blockchain, and that can follow the product the whole way. So we add these nodes to every company, and actually the smallest unit that you need is just a smartphone. We saw the biggest one is SAP, and the smallest one is a smartphone. So everything between there can be added to the system. So in this case here, when you are in the shop, or you are in the shop, you can just scan the fish package, and you can get information from every step in the production chain. And not only that the customer can get it, but you can also share information, as I said before, between the different nodes. And you have this settlement system, so you can actually now, instead of paying everything to the shop, you can pay the percentage that the shop should have. Then you pay a percentage to every node directly, how much they should have for this product. It's actually a copy from the music industry. There is solutions in the blockchain where you can download a song and you pay for it with crypto, and then what you are paying is distributed to the singer, to the guitarist, to the drummer, to the producer, to the songwriter. They get a piece of that information directly when you download it, on the second. Same here, when you buy the fish in the shop, we could actually pay a number of percentage to each producer exactly when you buy it. Creates complete new business models. Yeah, value proposition, it's more or less what I talked about. So that's my presentation very quickly. Questions?